Okay, the last topic we need to talk about with inverse functions is about their graphs. And the important thing to remember here is if AB is an ordered pair on the original function, then BA is an ordered pair in its inverse. So we can use that to draw some graphs here. I've got two graphs here, and then I want to play with some on Desmos. But if you look at this, let's see, this first one over here in red, the point 0, 0, let's see, 0, 0 is on the original. Let's say what instead of original, I'm going to call it F. And on F inverse, we're going to get the opposite of that, which is still 0, 0. Let's see, this point right here is, let's see, that's the point 2, 1 on the original. And so the inverse is going to have the point 1, 2. This point up here, that's the point 3, 4 on the original. And on the inverse is going to be the point 4, 3. So let's, I'm going to switch to a different color. I'm going to use this dark green. So points on, let's plot these points here. We got the point 0, 0. We got the point 1, 2. And we got the point 4, 3. And since these are lines, I can just connect them together. This is going to go down there. This is going to go up to here. So that green graph there is my inverse of that function. Now, one thing to notice, the line y equals x is a line of symmetry. If I were to draw that in, I'll draw it in red. From here up to here. That is a line of symmetry between the original function and the inverse. So I sort of picked the points that are nice, but I could have come through here and picked some uglier points. Like the original thing had this point right here. What is that? That's 1, and it looks like the y-coordinate is 1/2. I guess it's not that ugly. So that means that over here we'd have the point 1/2, 1. If you go over here, 1/2, 1, yeah, it goes to right there. So yeah, for every point you, by switching the x and y coordinate, it really just reflects it across the line y equals x. So we can do the same thing over here on this other function. Let's see, I can't, I'll just, well, that's good enough. If you look at this, the original has the point -1, 1, 0, 0, let me put that underneath, 0, 0, 1, -1, and I guess we need a few more. Let's go with this point here. What is that? That's -1.5, 3. And let's also do this point here. What is that? That's the point. That's what is that? Each one of these little tick marks, there are 5 of them per number. So let's see, 1, 2, 3, 4, 5. So this would be 1.2. And it looks like the halfway point there is 1.1. And the y-coordinate's -2. So on the inverse, we're going to have the point 1, -1, 0, 0. This is going to give us a -1, 1, then 3, -1.5, and -2, 1.1. Let's plot these, and we should get the mirror image of this thing. So 1, -1. 0, 0, -1, 1. Interesting. Actually, that makes good sense. So we get those and we get everything in between. So we get this. And then negative 1, 1. Oh, wait, I already did that one. 3, negative 1.5. So that goes off of my chart. 3, negative 1.5 would be down here-ish. Let's see, maybe closer to there. You can't see that. Let me adjust this slightly. Yeah, 3, negative 1.5, and then negative 2, 1.1. So negative 2 is going to be back here, then up to 1.1 is there. So I get this and this. And that actually makes pretty good sense, because if you draw the line y equals x, I'll draw that from here up to here. Oh wait, I'm starting in the wrong place. I've got to start here, go up to there, roughly. If you reflect the original across that line, you get the reflection. Now let's play for just a minute on Desmos. I don't think I've got any more examples on here. Nope. Let's look at some examples on here. If I come back up here and I put in y equals, let's go back with our original thing that we looked at. Our function f of x equals 2x plus 1. If I put in the inverse of that, which is y equals, let's see, we did x minus 1 over 2, we get that. And they are reflections of each other right across the line y equals x. And tell you what, let's do. Let's go back and put in one of the uglier problems that we did earlier. Let's do this example. So our original graph was y equals 1 minus x over 3x plus 1. And we found the inverse of that to be y equals x minus 1 over minus 3x minus 1. Okay, that's kind of boring. These two graphs look exactly the same. Why is that? Well, I guess maybe it's not boring. Well, let me switch over here so you can see it better. I said that, and then I said this is boring. These two graphs are exactly the same because they are already symmetric with respect to the axis. Let's maybe look at the other example. The other example was y equals 3x plus 1. Over 2x plus 5. Let's get rid of this. Oh yeah, this is going to be more interesting. When I graph its inverse, it's going to reflect across there. So let's see, its inverse was, let's see, we had two versions of it. One of them was y equals 5x minus 1 over 3 minus 2x. So we get that. And notice the if you were to reflect this graph across the line y equals x, the black graph would land on the blue graph. And notice the only places where the black graph and the blue graph overlap are on the line y equals x. All right, I think that'll do it for this section.